All right, so this is exam one, part one, problem five of the multiple choice. Oh, sorry, not problem five. This is going to be problem two. Problem two. Okay, so what problem two says is two large insulating parallel plates carry positive charge of equal magnitude that is distributed uniformly over their inner surfaces. Rank the points 1 through 5 according to the magnitude of the electric field at the points greatest to least. And so one way of thinking about this is here are the points. Here are the two uh, large plates. And when they say large plates, this kind of implies that we can kind of consider them as infinite sheets because the distance out here is very small compared to the size of, since it says very large, to the size of the plate. So we can kind of consider these plates as infinite sheets. And just kind of a side note, infinite sheets, the electric field is independent of distance. So that's now one way to think about this to remember is that um, electric field lines don't cross. Remember, if you remember that. And then also electric field lines start on positive charges and they end on negative charges. And so if you remember in class or in our lab, we had video tutorials kind of where we had a positive and negative charge, and it would start on the positive, end on the negative, and it would look something like this, right? Look something like that. Kind of like that. But in this case, let's consider how it would look if we had two positive charges. So if we had two positive charges, now I'm going to end up relating it to positive charges here. So the electric field, remember, the electric field lines don't cross, and they always have to start from the positive. So the way that this would look is something like this. Oops. It'll look something kind of like that. This is what the E-field lines would look like. So notice in between we have no E-field lines. The electric field is zero here. And so if we think about it and transfer that same logic to over here, the E-field lines are going to start to look like this. Oops. They don't cross, and they start from a positive charge. And so if you can take a look in zone 2, let's call zone 2 in the middle of these plates, the E field line, or the magnitude of the E field, is 0. There's nothing in here. But away from the plates, we're going to have a uniform E field going out. I guess I can draw out that way. Same thing here. And so in zones 1, so on the left side of this plate and the right side of this plate, we have a uniform electric field, and it doesn't matter at where the E field, because of this plate being so large, think about it that the electric field from this part is going to cancel out from the electric field from this part, and it's literally just going to keep pointing that way. So essentially, the magnitudes of electric field of 1 sorry, of 2 is equal to electric field of 3, which is equal to 0. And then the electric field at 1, which is over here, 1 is going to be equal to the electric field at 4 and the electric field at 5, and will equal some magnitude. There's going to be some magnitude here. We'll have some field. And so this will be greater, and then this will be the least. Okay.